Alright, we are on our last notes for this unit. We're going to talk about electrons again in these notes, and these notes are called valence electron configurations. So we're going to talk about those special kind of electrons that sit on the outer shell called valence electrons. Our first question of these notes is going to expand on our knowledge of how electrons are arranged in an atom. So the first thing that we said that electrons are arranged into energy levels or shells. These electron shells are designated by a number, like 1, 2, 3, 4. Remember, 1 is the closest one nearest to the nucleus, and as you go out further and further, 2, 3, 4, 5, 6, and so on, you get farther and farther from the nucleus, and you also get higher and higher energy out there. Here's a good picture example to show you. So in the middle here we have the nucleus with the protons and the neutrons, and then around it we have these shells. Alright, and so the shells are actually designated by the numbers. So we have the first shell here. This is the second shell. I know there's two lines. We'll talk about that in just a sec. And then here's the third shell, and here's the fourth shell. So remember, those big numbers out front are designated the shell numbers. Now, electrons are also divided or organized into subshells. So each of these shells has subshells, and remember, those are designated by the letters behind it. So in the first shell there's an S subshell, in the second shell there's an S and a P subshell, and again in the third, in this picture, the third subshell has an S and a P, and the fourth subshell has an S as well. So those are the subshells within the shells. It gets, kind of confusing, but if you keep it, kind of organized in your head, this should make sense. Alright, so here we have our notes for those sublevel or subshells. So again, they're designated by a letter, either S, P, D, or F, and remember that the electrons in a subshell are going to move within that subshell in a specific shape. So the S subshell is the sphere shape, and the P subshell is the dumbbell shape, while the D subshell is like a flower shape, and the F subshell is a really, really complicated shape. Alright, now we're going to take it one step further. This is the last step. The third level of organization of electrons is orbitals. Okay, so sublevels contain a certain number of orbitals. Each orbital holds a maximum of 2 electrons. Alright, so each subshell will have a certain number of orbitals, and each orbital holds a maximum of 2 electrons. So the S subshell is the smallest subshell. It only has 1 orbital. Therefore, the S subshell only holds 2 electrons. The P subshell has 3 orbitals. Therefore, if it has 3 orbitals and each orbital holds 2 electrons, the whole entire P subshell can hold 6 electrons maximum. Alright, and so as we get further and further out, the subshells are going to hold more and more electrons. So for example, the D subshell has 5 orbitals. So that means the whole D subshell, okay, that flower-shaped D subshell, can hold up to 10 electrons maximum. Alright, and then the final subshell, the most complicated one that we're going to study at least, is the F subshell, which has 7 orbitals. So 7 orbitals times 2 electrons each is 14 electrons maximum that subshell can hold. So if we take a look at it in this picture, the S subshell, again, remember, can hold 2 electrons maximum. The P subshell can hold 6 electrons maximum because there's 3 orbitals in that one. The D subshell holds 10 electrons maximum. Alright, and then the F subshell, the crazy big subshell, has 7 orbitals, so it can hold 14 electrons maximum. Alright, the last picture that I want to show you here is a really good one to kind of visualize the level of organization of electrons in an atom. So the biggest level of organization is the energy level, right? Or what are called shells. The second level of organization, we get a little more organized, and that's the sublevel or the subshells. And then in those sublevels or subshells, we have the orbitals. All right, so the electrons are in the orbitals, and the orbitals are in the subshells, and the subshells make up the energy levels or the shells. Alright, so it's important to know that electrons in an atom want to be in what's called the ground state. It's the lowest energy state possible in an atom. So what they do is they're going to start filling up those subshells, shells, and orbitals closest to the nucleus first, and then they go outward as they fill up, the seats around the nucleus. This is called the Aufbau principle. So our second question of these notes is, what is the Aufbau principle? It is basically the fact or the principle that says that electrons fill up their shells from the nucleus first, and then they go outward. So here's a picture that kind of is supposed to sum it all up, all the different energy levels and how electrons are kind of seated in these energy levels, shells, and orbitals and such. So in the middle here we have our nucleus. All right. Now the first ring around the outside is the first energy level or the first shell, all right, which is made up of the S subshell. All right. And so the circle right here is going to represent the one orbital that the S subshell has. All right, and then those little arrows in there are the two electrons that sit in that orbital. All right, so that is the lowest energy that electrons can have. So any electrons that sit in that 1s shell, subshell, and orbital are going to have really low energy. Now once that those two spots are taken up, any other electrons that are in the atom are going to have to go to the next shell. So the next shell that's going to be filled up is the 2s. Okay, so we're in the second shell. Now we're in the S subshell, and here again is our orbital. Okay, with the two electrons in it that are filling up that subshell. All right, and so if the atom has more than just 4 electrons, 2 in the 1s and 2 in the 2s, then they have to go to the next level out, okay, which again is the second shell, but now we have the P subshell, and remember P subshells have 1, 2, 3 orbitals, which hold 2 electrons each, and so that 2p subshell has 6 electrons in it. All right, so that 2p has 6 electrons. And then again, if there's even more electrons in an atom, it goes to the next highest shell. All right, which in this case is that 3s subshell. Okay, so it's the third big shell around the nucleus. It's the S subshell that gets filled up. All right, and again, the S subshell only has 1 orbital, so it's got it can hold a maximum of 2 electrons. In this example here, there's only 1 electron in it. That's okay, because there's no other electrons in that atom. That's kind of where it stops. All right, so if all of these spaces are filled up in this order, then the atom is at the lowest energy state possible, which is called ground state. All right, so that's kind of complicated. If you have to go back and kind of re-go over this part of the notes, it is a complicated kind of lesson to learn. So if you need to go back and do it. All right, I've said it before that the periodic table is a work of genius here, and you're going to see another reason why in our third question, which is, how does the periodic table show us how electrons are arranged in the atom? So let's take a look at the periodic table. If we take a look at this picture here, this is an outline of a periodic table. You can't see the element names because it tells us some other information about the periodic table. Alright, so the periodic table is going to tell us how many shells an atom of an element has. Alright, and so remember the row number or the period number here is going to tell us shell number. So this tells the shell number. Okay, so you know, an atom that sits right here is going to have 4 shells. We know that because it's in the 4th row, okay, or the 4th period on the periodic table. Now, the periodic table is such a work of genius that it also shows us, all right, the number of electrons in each of its subshells. All right, and so that's what this S block, P block, D block, and F block mean. All right, so what that's telling us is that all of the elements in these first 2 columns, all right, are going to have their valence electrons in an S subshell. All right, so their last electrons are going to be in an S subshell. All of the transition metals right here are going to have their valence electrons in a D subshell. Okay, and any of these guys over here on the right hand side, all right, all of their last electron is going to be in a P subshell. All right, so you know, if it's up here, it'll be in the 2p subshell. If it's, you know, down here in the periodic table, its last electron will be in the 5p subshell. But either way, it's in a p subshell. All right, and then the last one are these lanthanide and actinide series of elements, and their last electron is in an F subshell. So we call that the F block. All right. Now there's a kind of a handy little acronym that you can remember for the order on the periodic table, and that acronym is San Diego Padre fans. So whether you're a San Diego Padre fan or not, you can remember the order of S, P, D, and F on the periodic table by remembering that acronym San Diego. So San Diego Padre fans, SDPF. All right. So lastly, the periodic table also tells us how many electrons are being held in each subshell. So again, remember that the period number, the row number, tells us the shell number. Okay, then we have the S block, D block, P block, and F block, and how many columns wide those ones are is how many electrons they can hold. So you see that the S block, right, is 2 columns wide. All right, right here. It spans 2 columns or 2 groups on the periodic table. Therefore, we know that the S block holds 2 electrons. Over here, the P block spans 6 columns wide. So, because it spans 6 columns wide, it holds 6 electrons. All right, same with the D block. The D block is 10 columns wide, and so it holds 10 electrons. And finally, the F block is 14 columns wide, and so it holds 14 electrons. So again, the periodic table is a total work of genius. When you know all these little tricks, it's like, oh my gosh, how did they do this? So that's how it works. So we're going to see why we even need to learn this, all right, in the next question. Okay, so chemists like to keep track of all of these electrons and where exactly they are in an atom. And so to help us keep track of where these electrons are, we have to learn about what's called electron configurations. All right, so an electron configuration is a shorthand way of keeping track of electron placement in an atom. So we see here in colorful letters and numbers an example of an electron configuration. In fact, this is the electron configuration of chlorine. So to get an electron configuration of an element, what we do is we have to figure out what these letters and numbers mean. So first off, the red numbers out front, those are the shell numbers. Okay, because if we take a look at our periodic table, chlorine, okay, is in the 1, 2, 3rd shell. So the biggest number that we have in our electron configuration is 3 because it represents the 3rd shell. Now the letters are the subshells. Okay, so we've got S subshell because here's our S block over on this side, right? And we've got the P subshell represented, that's over here on this side. And chlorine, which is in that 3rd shell right here, is doesn't have anything to do with the D block, so we don't have a D in our electron configuration. So we've got S and P's that we fill up, and then our last bit of the electron configuration is the numbers. Alright, the numbers up top. And those actually tell you the number of electrons that are sitting in that subshell. Okay, so we can see that the 1s subshell has 2 electrons in it, the 2s subshell has 2 electrons in it, the 2p subshell has 6 electrons in it, the 3s subshell has 2 electrons in it, and lastly the 5p subshell only has 5 electrons in it. So that the last electrons in chlorine sit in the 3p subshell. Alright, so here we've written down those explanations of what are the different things in the electron configuration. So again, the big number out front is the energy level or the shell number. The letter represents the sublevel or subshells, and the small, what's called a superscript, or the small number up on top, is the number of electrons in each of those subshells. And last but not least, and perhaps even more importantly when we're looking at electron configurations, is that the ending part right here, the last big number, letter, and superscript, tells you the identity of the atom. It's going to tell you exactly where that last electron sits, and wherever that last electron sits gives you the identity of the atom. So for example, in this sample, we know that it's in the 3rd shell, alright, so the 3rd row down. It's in the P block, alright, which is over here, and it sits in that 5th spot in the P block. So 1, 2, 3, 4, oh, there he is. Chlorine is number 5 over there on that P block in the 3rd shell. So that last ending part tells you the identity of the atom. Alright, so let's take a look at and start practicing writing these things out if you're just given like an atom name. Okay, so our last question for these notes is, how do I actually write out these electron configurations? Well, the first rule is that you always start at the top left-hand corner, okay, up here, with 1s. That's always going to be the first shell and subshell that gets filled up in an atom. It's got the lowest energy, and that's exactly what atoms want to start with, is the 1s subshell. So if we're going to make an electron configuration for strontium, who's way down here, we're still going to start with 1s. Next, what you'll do is you'll read the shells and subshells from left to right until you reach your element. So for strontium, we start here at 1s, and we have to fill up this row. Alright, so when we fill up this row, there's only 2 spots in this row. So 1s2 is what we start with. Okay, that will bring us to helium. Now we go to the next row, okay, and we go 2s, and we fill up that row with 2, so 2s2. Then we keep going across that row, and we hit 2p, and there's 1, 2, 3, 4, 5, 6 spots, so that's 2p6. And we're still not at strontium yet, so we keep going down to the next row, which is 3, shell 3, and we have an S subshell that has 1, 2 spots in it, so that's S2. So 3s2, and again we keep going across the row over to 3. Now this is the P section, right? And there's 1, 2, 3, 4, 5, 6 spots in that one. So we fill up all 6 spots, so 3p6, and again we're still not down to strontium, so we keep going down to the next row. And this row is 4, and we fill up the 2 spots in the S block, so 4s2. Now here's where it gets a little more tricky. When we get to the D block, those transition metals, I've always told you before that they're going to screw things up, and they screw things up now again. So instead of being 4D, it's actually 3D. Okay? So the transition metals, or the D block, are always one shell below. So that first row is not 4D, it's 3D. And then so that makes the next row 4D, and the next row after that 5D, and then 6D. Okay? So when we're doing this configuration for strontium, it's going to be 4s2 down to 3d. Okay, and again there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 spots there. So 3d10. And again, we're still not there. So now we are in the P block, and the P block jumps back up to the original row number. So this is going to be 4p. Alright, and 4p has 1, 2, 3, 4, 5, 6. So we're going to do 4p6. Alright, still not to strontium, so we go down to the next row, and we are almost there. We've got row number 5. Okay, so that's shell 5. We have the S block, and check it out, strontium's last electron sits at that second seat there, so it's 5s2. So this is the entire electron configuration for strontium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Ay, that was a lot. Alright, so it's a lot to digest. If you need to go back and re-look at any parts of these, please do that. Tomorrow in class, we'll be doing lots and lots and lots of examples. Once it clicks, it's really easy, so don't give up, and we'll see you tomorrow for the activity.